So, um, I'd like to welcome you all coming to this GloBIAS seminar series, the first one of this series. And today we start with 10 minutes introduction about GloBIAS, because this is probably the first time that it's really in public. We are presenting GloBIAS. And then we welcome Haase, who is also part of this steering committee, and then he's heading, actually, GloBIAS. We'll give a talk about large language models. And then actually, this seminar series focuses for this coming month about large language models. And then this is the first one of this topic. Okay, so let me give you some introduction about GloBIAS. It's very easy in a sense, because bioimage analysts who are experts in bioimage analysis are lonely. They are standalone, mostly not forming groups, and then working surrounded by people who doesn't know much about bioimage analysis, fighting every day. Bioimage analysts are lonely, and then we want to network them. And then we did this already in Europe. And then as you see here, so yellow marks are potentially some bioimage analysts located. And then we network them since 2016, and then we have been pretty successful. Now, we want to do this globally, so that's GloBIAS. So what was GloBIAS? GloBIAS started in May 2016, and then we did many training schools. We published textbooks. We started F1000 journal for bioimage analysis. We created tool database, benchmarking, career path development, and then also we did 4 times annual multiplex conferences, and has attracted really many people. So we wanted to continue, but then the corona started, and then we switched to online seminars. So I think most of you that are watching this came to know GloBIAS through this GloBIAS Academy, which has tremendous hits. So we do this, expand this to the global scale. So that's the plan. So before anything, so we just like to mention these all these people who has been contributed a lot of efforts in making GloBIAS success. So that this is acknowledgement already. And then also there's a different team for GloBIAS Academy. I would say second generation GloBIAS people, like Rocco, Olivier, Bram, Elnas. Ofra was actually one of the traditional member, and Romain, Robert, who is giving talk, Anna and Florian, Marion, that's me, but Paula, Mafalda, and Tishi. Okay, so now, in a nutshell, our common interest in GloBIAS is scientific measurements of biological systems using image data. And then what we plan to do as a society is that we do a lot of interactions, which you see in the next slides. And then we create new values. And then if we let them just go, it dissipates. So we try to keep them in some resources such as books or websites or web database and so on. And then those resources triggers next interactions, which is, evolves with more potential in doing better bioimage analysis. So this was a kind of how we have became successful in GloBIAS, but we didn't have a strong administration backbone. For example, we didn't have stable source of financial resources. So it has been very fragile. So we want to make it stronger. So that's why we are switching from network to society. And then society needs a lot of preparations. And in fact, we are in still preparation phase, but it's gonna start up very soon. And this will be, Krista will talk about this. Okay, so it's a network, not only being lonely, but it's a lot of fun meeting other bioimage analysts. It's like among all the monkeys, you finally find a human who you really can talk to. So that's the network of experts. So this was a slide that was made in 2017 after the first conference, but you see the robot is here very seriously working on, and he's going to talk about his topic, what happened after years, and now it's a large language models. Okay, so I switched to hand over my slides as the explanation about GloBIAS to Krista, who talk about the current status. Okay.
So welcome everyone. So I am Krista Walter, the community manager of GloBIAS, and I want to give a short introduction or the overview on what GloBIAS is at the moment. The aims of GloBIAS are defined by the grant that was submitted to the Charles Zuckerberg initiative that was part of the call Advancing Imaging Through Collaborative Projects. This grant proposal was received funding beginning of 2023, but the project only officially started with the appointment of the community manager in September. During a survey beginning of this year, we actually contacted people asking them whether they would be interested in contributing to GloBIAS, and we now have 40 volunteers working together with myself as the community manager and our steering committee members. And we have a range of tasks we are working on, and the main bits are to establish the non-profit association. As Kota already mentioned, we want to officially register as an association this year. We want to foster the knowledge exchange between our members. We want to develop a curriculum for bioimage analysts. We are working on the creation of repositories for training material, which we then also want to continue to maintain. We are working on consolidating standards for bioimage analysis, and we want to regularly organize in-person and online events. So we're starting with a seminar series where we plan to have more things happening. And now if I manage, okay. So, and now I want to give a few points on the idea behind the seminar series. The idea actually came out of the training and education work group. This is actually the largest group we have in GloBIAS. We have several working groups. Some are working on the workshop, others are in the training education. We have a comms team and a publication group. And if you are interested in learning more about this, I recommend visiting our webpage. As mentioned, there was a subgroup in the training education group who wanted to organize a seminar series. And the aim really is to provide a dynamic platform for bioimage analysts that allows us to showcase latest development in the field and foster community interactions. And the seminars are supposed to be catering for intermediate and advanced analysts and focus on content that extends beyond basic instructions. So this is all from my side. I hand back to Kota, who will introduce robots.
This seminar became available with support of this Zoom from Broad Institute in USA, which is the help of Beth Cimini, and then Esteban Miglietta, he will support in background. So especially with the question that you would have. Okay, so I would like to introduce Robert Haase. So Robert Haase finished his PhD study at the medical faculty at TU Dresden in 2013. Then he started working as a bioimage analyst at the Max Planck Institute for Molecular and Cell Biology and Genetics in Dresden in 2015. So soon after that, he joined the first Novias conference in 2017 in Porto, which the picture I showed just previously today. And then he became a group leader at TU Dresden in 2020. And then since 2023, Robert has been working as a lecturer and a training coordinator at Leipzig University, which also is in Germany. Okay, please welcome Robert.
Hello, everyone. I will just share my screen. So thanks first of all for the introduction, Kota, and also for the people in the GloBIAS seminars working group who were organizing that behind the scenes. So it's great that we can basically come back to the good old tradition we had in the new BIAS age, where we had these webinars and met regularly. I hope that this will fly again. The first seminars, the first 3 GloBIAS seminars are planned, and I'm glad that you all made the time to come here today. So the topic today will be large language models, an introduction for life scientists. You see a link here. There will be also a link in the chat in a minute, I presume. So let's dive into this. There's a huge field, let's say. We are sitting inside neural networks topic-wise, and we talk about LLMs, large language models, and there's a lot of terms around. So vision language models, image generation language models. There's this huge discussion topic, prompt engineering, embeddings, retrieval augmented generation, RAG, and there's also function calling, fine-tuning. I will try to manage through all these topics I have 45 minutes left. I hope there will also be time by the end that we can have a short discussion about these things. So first of all, as I mentioned already, large language models are a form of neural networks commonly used nowadays, for example, for tasks like this one, for translation tasks, where you take an English sentence, you somehow put it into this neural network, and then there comes a German sentence out on the other side. And I would like to highlight at the very beginning, when we are all still like very awake, is that there is also some aspect people talk a lot about in the context of large language models where they were not made for, but they are used for that quite often. So for example, knowledge retrieval or information retrieval. If you ask a question to a large language model, you may receive an answer, but you may also receive a hallucination, and often you cannot even differentiate between these two. So this was not the original purpose language models were developed for, but nowadays there's a lot of discussion about how we can use them for this particular purpose. One paper which came out, I think it's already 2 years old, is about retrieval augmented generation, RAG. I will also tell a bit more in detail later what that means. But this is maybe one of the most promising approaches in order to reduce hallucinations. And if you want to read a little bit about this technology, I put a link here. There's also a lot of discussion about if large language models can do reasoning, if they can work like a scientist. So you put in a hypothesis on the left side, and then this large language model responds with a proof and an explanation. Of course, that would be fantastic, and maybe this technology is developing to that point, but maybe also not. Also here, I think this paper is something like a week old. So have a look at these kind of publications in that direction. People are actively working on that. At the moment, I would claim that large language models have serious issues in particular in scientific reasoning. What is a much more common use case where I will also talk a lot about, because also that's where my expertise lies, is the translation task, which is code generation. So you take English text and you translate it to Python, which can then be executed. And also here in this context, there are some papers out, one which I found very fascinating is the software engineering benchmark, where the authors asked if large language models can solve real-world GitHub issues. And in very short, the answer is yes. And it's also becoming with time better and better. So there's apparently something where we as a community, as a scientific programming community, can profit from a lot. And I would like to explain also a little bit more in detail why I think this is so important. Large language models are often criticized for if you ask for an output, the output has limited reproducibility. So it may or may not answer the same answer if you ask twice. Also, they are hard to evaluate. So in particular, if you ask a question where you do not know the answer, how can you afterwards verify if the answer is correct or not? With an example, a very simple example, I would like to introduce this topic a little bit like this. If you say to a language model like ChatGPT, say A, it may then say A. But if you ask a second time, it may answer with a different answer. So one this is A with dot, and one this is an A with exclamation mark. So this is what I mean with reproducibility in a very simple sense. Language models answer differently from time to time, and this may or may not be solved on a language model level. The alternative is you ask for code from the language model. So you ask the language model to produce code to solve a certain task, and then this is more reproducible. So for example, if I ask the language model, please write Python code that says A, then it will produce this code, and no matter how often I execute this code, the answer will always be A. So this is reproducible. So this kind of aspect, code generation with language models, is a potential solution to the reproducibility issues of outputs from large language models. And that's why I'm very fascinated about that, because I don't have to think so much about the limited reproducibility of large language models. There's more applications I would like to just show. So for example, you can ask a language model to please produce a histology image of lung cancer cells and some healthy tissue. So it will then produce an image. And it's very obvious that this is an interesting challenge for our community ahead. I think in particular, those who work in histopathology can easily identify this image as a made-up image because it has some structures which you may not find in real images from cancer patients, for example. But these models become better and better. And we have already seen like serious fraud in producing images and producing text for scientific purposes, which is certainly not a good idea. And we as a scientific community have to figure out ways how to deal with that. On the more positive side, on the more useful side, I would to highlight this particular aspect. So if you feed in an original microscopy image like here, blobs.gif on the left side, and a sentence like blur the image, there are models which can do this particular modification or this variation of the original image, and then, for example, blur it and make it like better quality. So this is here the Instruct Pix-to-Pix paper. Also, this one highly recommended if you want to dive deeper into this particular direction. But also here again, reproducibility issues. Yeah, there's a notebook also linked here on the bottom. You can try out this algorithm for yourself. And the problem we as a community still have to solve in this context is if you ask twice to solve this task, you get different results out. So then also the follow-up processing and segmentation also on may vary depending on this particular output. So there are still some things to do. What's also interesting is that you can ask language models to describe images. So that's basically the opposite direction. I put in this image and I ask what is there in the blue channel, and then a language model might, for example, so this is a made-up example, answer with there are presumably stained nuclei with DAPI using a fluorescent microscope. So this is kind of output which could potentially be produced by a language model. And what would be really nice if we could come to a point where we feed in a microscope image, a task like how many cells are there, and then there is a segmented image falling out together with a description or together with a sentence like there are 4 cells, I just marked their nuclei. I'm not aware of any implementation of this yet, but I think it is, from a technology perspective, not far away, and we may see popping up algorithms or models like that in the coming years. Okay, one step back, I would like to introduce a little bit how the technology under the hood works, and I stay on the surface just because of the limited time. So the traditional architecture we were using a lot in microscopy and image processing in the last years are these so-called encoder-decoder networks. So you see on the left, there's some input neural network layers. They change a bit the shape toward the center. And then on the right, there's again neural network layers built up to produce an output. So you could, for example, feed in on the left side a noisy image, and on the right side, a denoised image might fall out. So you see here, this is a UNet visualized, which approximately works like the algorithm noise to void you may have heard before. The green area in the middle which has a different shape, which has not the same size. This neural network layer does not have the same size like the original image, but also a different dimensionality, is sometimes called latent space embedding, or the bottleneck in the network. And it's basically an abstract representation of the content of the image. Also, some of these networks have these so-called skip connections, like it was kind of normal for the UNet we are so used to in microscopy image analysis. The key information I would like you to have a quick look here is that we basically have two things. We have an input image and we have an output image, and we train the network to produce the output from the input. So there's two things, in and out. And there's this new architecture which was published 7 years ago already. It's the transformers, which look like that. I will simplify it in a second. All these colored boxes you see there are neural network layers, and also within these boxes there are multiple neural network layers. So this is actually a huge network architecture which does some processing. And now I will quickly just simplify it so that we can have a closer look, which is also here on the left side, you have an input, you have on the right side, you have an output. Also, these are sometimes called encoder and decoder. So the idea is still the same, but the difference is that we have now three things which are connected to this infrastructure. So you see again on the left, there is some input, and on the right, there is output and shifted output. And there's also a masking in between, which is necessary during training to avoid that the network just learns output from output and doesn't consider the input only. And now I would like to show you what these 1, 2, 3, what these things are. So for example, I could put in translation task a German sentence on the left side, die Katze sitzt neben dem Mikroskop. And I would then get an English translation out. The cat sits next to that. And this is also what I would feed in at this point there at the 3 to predict the next word. And then this network, this transformer, would, for example, predict the word microscope. So this is basically how it works. It is in this particular context, you see that we are feeding in on the left side German input, and on the right side, we feed in output, which was already generated. So like the first half of the sentence, which was generated before, and then it can predict the next word depending on the German original sentence on the left and the words which were already translated. So this is now basically the architectural big difference between the networks we were using in the past years and this transformer architecture, which now allows us to basically transition between different forms of the same information. In this case, we are translating from German to English, but there is also networks out there, and I've shown them already, which can also translate between different media, between different forms of data. So you can feed an image like on the left, and you can submit a partial translation like the cat sits next to that. And thanks to the information which is embedded in the image and which is embedded in this half sentence, the network will then be able to complete the sentence and say a microscope. The cat is sitting next to a microscope. And this is this multimodal architectures we are seeing these days. What I find also very fascinating in this context is that we basically went away from downloading a single network and training it on our data, and then we have a trained network. We are now in an age where we can basically take parts of networks or modules from different architectures, combine them with each other, and then, for example, build a huge architecture which combines image processing and text processing in one architecture to, for example, describe an image or produce code which is possibly can process an image. So these kind of things are new here in this particular context. One example I found very nicely written and explained, also this preprint, is the use case is descriptive biology. So you can, for example, take images of samples, so here fly wings, and you can pass them to a language model, and you can then have discussions with the language model and ask the language model about to what degree these wings are normally shaped, or if there are any abnormalities. And the authors said also in their conclusion that, of course, visual language models are in their infancy, but they already show some potential for multiple applications in automated phenotyping studies. So that's very interesting. And they encourage the community to carefully test them. And I would also encourage everybody to play a bit with large language models, with vision language models like shown here, and see how they can be useful in your particular domain, because we will certainly see more and more studies of that kind coming out. So one more example, also the same direction, but this time quantitative biology. vision language models were not exactly built for this particular use case. So I'm handing over a microscope image, and then I ask how many nuclei are in the blue channel, how many blue nuclei are in this image. And ChatGPT on that day, when I asked it, said there are 3 blue nuclei visible in this image, which is obviously not true. So I was making jokes about that slide and carrying it around for some time, but actually I should not, because my n equals 1. So I was a bad scientist here in this context. I did not do this study properly. But then later I tried. So I uploaded this particular image and I asked the language model 25 times, analyze the following image by counting the bright blobs, respond with the number only, and then you can basically plot the count over the language models. So and here you see 3 models from OpenAI from November 2023, from April and May this year. Maybe I should run it again with the current model, which is out. And you see that this distribution of counts is changing and it's becoming tighter. So I'm not sure if OpenAI, if the engineers there think about this particular use case, this particular image, but apparently these models are over time becoming better for this particular task. It's certainly not at a point where I would use it in a research project, but this technology is obviously evolving in a direction where it might become useful for these kind of use cases. And yeah, in particular, when we think about something becoming useful for image analysis, we have to think about benchmarking. How can we measure how good an algorithm is, how good a language model is, and how can we, for example, observe that over time until we come to the point where we are convinced that the technology is ripe to be used. Just as an example, you see here on the left, microscope image, then it's binarized. From this binary image, I derive an instance segmentation using connected component labeling. I measure the area of all these individual objects, and I compute the average area. This is the workflow I quickly take as an example. And you see here on top a prompt which explains exactly that. So this function implements a workflow consisting of these steps. O2's method, label connected component, measure the area and determine the mean area of all objects. This is what I sent to a language model. And what I also have, but which I do not show to the language model, is a reference solution. So this is some Python code, a human, in this case, I wrote, to know how this problem can be solved. We also have some Python code which tests if a potential solution, some generated code, has the right result. So we have formulated something like 57 of these use cases. The community, so some colleagues from Germany and also from the US, from San Francisco, we are contributing more. And this is also open for your contribution. So if you see that in our list of use cases, you find here links on the bottom to the preprint of the GitHub repository. If you have the feeling that our list of use cases is incomplete and there's important stuff from your subdomain missing, please reach out. We would love to have you on board and contribute to this paper, and you can certainly become co-author before it comes out. So coming back to this example where you just saw the code, if I ask different language models to solve this, to produce code for that, and then we execute the code and we check if the results are right, you see here multiple language models. For example, Claude is leading at the moment, and there's also behind different GPTs, Claude, and Gemini from Google. In the middle of the screen, you see some open models, which also are capable of solving this kind of particular task, but only in half of the cases. So something like a likelihood of 0.5 means that, yeah, just half of the solutions from these 10 iterations, only half of them were functional, the other half were not. On the right, you see the open models, which were unfortunately only very rarely able to solve this particular task. And here you see on the left these 57 use cases we had. So you see that some tasks are easily solvable by multiple language models, including the open ones. And you see on the bottom of the screen, there are some tasks which were not solvable at all by any language model. Here we are also currently discussing if maybe we prompted in a wrong way. So maybe we have to modify that. But in very general, you see that there is variation inside the field. Again, Claude from Anthropic is currently leading since June, I think. And before we were for multiple months observing how different GPT models from OpenAI were leading the field. So we keep track of what's happening a bit in the community to have an idea of which models are capable of doing what, so that we can then also later use them in projects in a responsible way. Okay, So now that we know how good the language models themselves are, we may want to use some techniques for improving them. So we can take a language model and combine it with a technique called prompt engineering to make the result more likely functional. So prompt engineering, typically phrased as we modify a prompt until it works. It's a bit fun, but also a bit real. So for example, I could ask a language model, please write Python code to open the image blobs.tif, apply O2 threshold, apply connected component labeling, make a label image, visualize the label image. And then it would, for example, respond something like that. But I don't care about the blah blah before the code and the blah blah after the code. That's why I might also say in my prompt, do not explain the solution, just provide the Python code. And short comments are okay. So, and also here, it's now using some libraries I'm not so used to. It uses OpenCV. OpenCV I do not use often in microscopy image analysis because OpenCV is more made for natural images, for example, not for high-dimensional images. That's why I may also extend my prompt and say, please do not use these libraries. And then it comes up with a solution which uses matplotlib and scikit-image, and these are the things I'm used to, I'm fine to use in a project. So this is basically, I'm editing my prompt until the result fits to my expectation. And if this text I wrote here on the left becomes very, very long and maybe even like from project to project the same, this is what some people call a long context. So we basically provide a lot of information with our actual small task to have a solution which fits very nicely to what we expect. An advanced technique for prompt engineering is retrieval augmented generation. So let's have a look at how this in particular works. So it's an attempt to make LLMs more accurate or truthful. So I said that already earlier. And for example, the following situation could be useful. So I would like to know from the language model, how can I segment cells in a microscopy image? And the language model or the tool would then, for example, do the following. It has a database of different algorithms, CellPost, StarDist, O2, Watershed. And for each of these algorithms, it has an idea or some text, some explanation, what these are good for. For example, CellPost is good for segmenting cells, nuclei, cytoplasm. There's also the word cells in my prompt. So there is basically a technique for selecting algorithms from the domain-specific knowledge base, selecting some information and putting this information together with my original question, do prompt engineering, so putting these two together, and then this selected domain-specific knowledge and my prompt are sent together to the pre-trained large language model, and this large language model may then answer something like, try CellPost. It's well suited because this information that CellPost can be used for segmenting cells is in the domain-specific knowledge base. So technically, on a level below, it works using embedding. So you see here some Python code. It might not be interesting for everybody. But imagine an embedding is a high-dimensional space. So here I'm just showing 2 dimensions, basically a principal component analysis of this high-dimensional space. And you see some data points in there. So these data points, they correspond to words. You see in the top right corner microscope, and then quite far away from the microscope, there's black, white, and cat. So the distance to cat, from the colors to cat and from the colors to microscope is pretty much the same because there are black and white microscopes and there are black and white cats. Black and white themselves are close by each other because they are both colors. They are somehow related. But what is the most unlikely, basically, in this context, what can happen is that the microscope has a fur. And that's why the fur is so far away from the microscope. So distances in a word embedding in this high-dimensional space where there exist data points which represent words, the distances in there have a meaning. And if I would now, for example, search for cell segmentation in a word embedding where there are different algorithms embedded, CellPost might be the closest because I'm searching for cell segmentation and not segmentation of cats or microscope and photography images. So word embeddings are used to identify related documents, related information in this embedded space. This is basically the technology which underlies a lot of chatbots out there, or maybe you have seen it already. Chat with your PDF, upload your PDF to our online platform, then you can chat with it. So this seems often like a bit of magic technology. And here I put a link on the very bottom where you can read some Python code and you can basically try this out yourself. It is surprisingly simple with the current technology. Of course, you have to have some Python programming skills, But chatting with your PDFs and getting information out using retrieval augmented generation is surprisingly trivial. So if you want to try that out, there's the link. An advanced technique also related is called function calling. And function calling is basically the following. Assume you have a list of tools. These tools have names. There's one tool which is called get current time. There's another tool, order food. And there's a tool called book room. And now you have a task. And this task is please book meeting room number 3 for Robert at 3 p.m. Which is the right tool to use? This is basically a prompt. This entire thing I have here on the left side, I send to the language model. And then the language model will tell me the right tool for doing this is book room. And you can, it's a kind of next word prediction task. And you can basically, if you like, reproduce my prompting I was doing here, for example, in ChatGPT. So yeah, you see here on the right, it's the text I entered, and you see book room is the result which comes out. So that's step one. You want to identify a function which can solve a certain task. And step two is parameterizing this function. So given a function signature, so I have this function signature book room, and it has 3 parameters, room, time, person. And, oh, here's the animation broken. I'm sorry. And I have a task. Please book meeting room number 3 for Robert at 3 p.m. How could I use the tool? And then the language model could come up with a Python function call. That's why this is called function calling, which basically does exactly that. And if you look here on the left side, what we have, and on the right side, what I have, is some kind of a translation task. It's translating my English sentence into Python code so that then the Python code can be executed. And you can also run exactly that, and it will also explain a little bit how it's doing this. So you see here on the top right, that's the prompt I just entered, and on the bottom there's Python code which is doing exactly this. Of course, if you want to embed this into an application, if you, for example, want to program a microscope which can listen to a microphone, where you can give tasks, microscope, please take an image, microscope, go to a different Z position. You don't want to copy paste this between ChatGPT and your Python environment. So that's why there were a lot of development out there. Multiple libraries in the Python ecosystem now allow you to do these things. So for example, you see here, I'm telling an agent, show the image, and it is actually showing the image in my Jupyter notebook. And then I can also say, please segment the image and please show me the segmented result, and it will also do that. So again, if you want to try out these things and see that it's right what I'm claiming, you find here on the bottom a link to this notebook where you can discuss with an agent, with a language model to do image analysis processing steps, and it will do it. Last but not least, in this list of techniques for how to, what LLMs can do is fine-tuning. Also a hot topic these days because we want to have potentially models which can overcome current limitations. One very important aspect in the context of fine-tuning is that all the techniques I have shown you before, retrieval augmented generation, function calling, and also prompt engineering, the response time is quite long. So if you assemble a lot of information in the prompt, then you send this long prompt to the language model server, and they have to process this entire thing. It's quite costly, it's quite long, and fine-tuning a custom domain-specific large language model might be the solution for having faster responses and also getting the costs down. What basically happens, we have a similar domain-specific knowledge base. Here it says training data because it has to be reformatted a bit, but it's details. And I have a pre-trained large language model, and I feed these two into a fine-tuning process. And then I get a domain-specific large language model out. And this is basically a file or a model which I can ship to collaborators. And then the collaborators can say, how can I segment cells in a microscopy image? And the large language model would respond, for example, with cell pose, because this information was embedded in a domain-specific training data. So this is a more efficient way for answering questions by having these domain-specific large language models, but the fine-tuning itself is also a very costly process. So I would not just go for fine-tuning under all circumstances. If you want to try out fine-tuning, an OpenAI model or an open weight model on your local computer, there's also 2 notebooks where you can try out these things. I would like to highlight one thing. In order to get a good language model, a good fine-tuned language model, the challenge is not the code for doing the fine-tuning, the challenge is to get good training data. So I presume also here will be some development in the next years, and that's really challenging, at least from my perspective. So this is an opinionated decision tree in which situation you should choose which of these techniques. So if you want to decide between classical prompt engineering, these long context, retrieval augmented generation, or fine-tuning, you may follow these short discussion steps. If your knowledge base is pretty small, you can go for long context prompting. So you just put together a prompt. If you in your daily routine analyzing images, you are, let's say, using again and again the same 20 functions. You assemble them sometimes a little bit in a different way, but in very general, for denoising, you use the same stuff every day. For background removal, you have two functions you use. And for segmentation, there is also just a small selection of algorithms you are using. You could put all this information in a long text and then put it together with your prompt to the language model and ask the language model to produce code. There's no need to set up a complicated RAG or fine-tuning element. If you come to the point that this knowledge base is frequently updated, so every day there's a completely different task, and you want to give different information to the large language model, you may have to go for retrieval augmented generation. You may have to find a way how to structure your knowledge base in a way that you can, for example, with embeddings, easily pick relevant information for a specific task, and then the specific information, these details, are then submitted together with your prompt to the large language model. If your knowledge base is not frequently updated, but big, then fine-tuning a model might make a lot of sense because it spares you a lot of money later when executing this fine-tuned model, but you cannot retrain a model every day. That's too expensive. That's why this frequently updated is key in this context. Also, you have to have additional criteria in mind, quite obvious. So if you can fine-tune a super large language model and then you have a fantastic language model, but you cannot execute it because in your institute they don't have graphics cards. So that's obviously a limitation. You have to stick then to online services and cannot do the fine-tuning on your local hardware. Also, compute time and costs, keep that in mind. Fine-tuning is expensive, RAG can be expensive, and yeah, there's a lot of consideration in this particular context. Large language models are everywhere. So I was hiding half of the slides here, and I apologize, but for the time I had to. So if you download the slides, you will find even more than I'm showing now here. So first of all, there is not just ChatGPT. I've shown already that Claude, at least these days, in our benchmark, is the better solution. That may be different next week. There's also the opportunity to try out open models on the Hugging Face, Hugging Chat platform, and there you can choose from a couple of models and you can talk to them. So also this is highly recommended to try out. Then there's tools which embed these language models internally, so they generate code for you in the background and run it, like here, Napari, ChatGPT, Omega, and the Bioimage.io chatbot is, for example, a RAG, which consumes, for example, the ImageJ documentation and can give you better hints in this particular subdomain. And there will be GloBIAS seminars in the next 2 months about these two platforms. Obviously, also these are highly recommended to join. I'm also looking forward to these two presentations. Then there is a tool called Jupyter.AI. It's already a bit older. It's maybe the oldest tool I know where large language models are embedded in a scientific data analysis platform in Jupyter. So you can try this out if you are interested in general data analysis tasks, or BioBob, that's a tool I developed, which is a bit specific for bioimage analysis tasks. These two run inside Jupyter and can help you generating code for specific use cases. Also worth mentioning is GitHub Copilot. Many of you may have heard of this one, and there's a new tool. They are basically advertising a public beta these days. It's where you in the browser can solve complicated GitHub issues. And then the online tool will make a plan and will solve a GitHub issue for you so that you can spare time in programming. Also, many people are talking about Cursor these days. It's the Visual Studio clone where AI is very deeply embedded. So you see large language models are popping up in all our favorite data analysis and programming platforms these days. Also, what we have is an implementation of OpenAI's ChatGPT and Anthropic's Claude in Fiji. The code is actually a bit older, but I just managed on the last weekend to give it basically on the ImageSC forum to the community so that people can try it out. So you can use that, you can download that and use that, for example, to produce ImageJ macro code. I'm not 100% convinced yet that language models are good in this, and we do not have a benchmark at the moment for measuring it. That's why if you have time, please try it out, and report back in the ImageSC forum if this works well for you or not. So code generation is tricky. I think what it can be really useful for is if you have a long image.jl macro and it's not documented, you can ask the language model to put comments in so that you have a better time understanding what the code is doing. So therefore, that is really useful. Good. Eventually, I would like to also give some advice or some hints and thoughts of mine, maybe just about good scientific practice when using large language models. There have been a lot of discussions also on Twitter recently. We were discussing about these things. If you use custom code written for your particular project by a human expert versus an expert large language model, you definitely should understand the code. This is like, that's not new, thanks to language models. If you get from an expert some code and the code analyzes your data, you should not just trust blindly this code. You have to read it, you have to talk to the expert, you have to figure out what it's doing. That's your responsibility. So that's not new thanks to LLMs. It was like that before. You should also question used methods. So you should go to the expert and say, hey, look, why are you using this algorithm and not that algorithm? And maybe results would be different otherwise. You should check results carefully. So for example, by annotating some images, doing some manual measurements, and then comparing your manual measurements with what the code from the human expert or the LLM is doing. And you should certainly test the code on samples the expert didn't see. That also means you should not just ship all your data to an expert and ask them to analyze it. You should also keep some data for yourself so that you can do this later on. Blind the expert, at least to some degree, so that you can do some independent quality assurance afterwards. Also, where these two are a little bit different, in fact, you should pay the expert. Experts cost, if you get a cheap one, maybe $100 per hour. Language models are much cheaper, but obviously they may not be as experienced as an expert. You should also mention the expert. So for example, if you work together with a bioimage analyst in a project and they are helping you analyzing your data, they should be co-authors. We have had this discussion many times before. I see no other option here. So they have to be co-author. And if you use a large language model to produce code to analyze your data, you should, if you are a brave scientist, you should mention that in the methods of your paper. Sharing responsibility. You can share responsibility with a human, but you cannot share responsibility with a large language model. So here is a substantial difference between these two techniques. So a language model cannot be made responsible for errors in the code. You are responsible for the code. And you can ask the expert endless questions. That's not the case for human experts, because human experts have limited time and they have to sleep at some point and also have other projects to do. But an LLM has endless time and you can ask endless questions. So that's also a difference on the good side. Also, what I would kind of like to ask you is share how you prompted the expert. Maybe with a human expert may not work, but with the LLM, definitely. We are often hiding that we were using a large language model for solving a particular task, or we're just trashing the prompt after the task is solved. But we should actually keep these prompts, and we should also share them, at least with our colleagues, maybe even in a supplemental material of a paper, so that we can learn from each other. Only if I tell you which prompts work and which prompts do not work, only in that way you can learn. So if we would all keep the prompts we did in order to achieve a certain goal and put it next to the solved goal, that would be great for our community mid long term, because we can share knowledge like this. I prepared exercises. You saw it already on many of my slides. And here just one kind of reminder. If you want to execute these notebooks, you can go to this particular page. There are installation instructions. You have to set up everything on your computer. I would, in this particular case, in particular for the image generation and the vision language model exercises, I would recommend you use a workstation with a graphics card. If you are just using some code generation using the OpenAI API or using Claude or any of the other online services, you may not need a GPU. But for doing all the exercises I have shown in this talk, where I have put links to the notebooks, you have to have a graphics card available. So I will just summarize. So obviously, large language models can generate code to analyze biological microscopy images. Open source benchmarks can help to target further improvement and also to measure how these things develop over time. There are certainly a couple of challenges which remain unsolved, at least to my perspective at the moment, is, for example, identifying the best strategy. Should we fine-tune a model, or should we use a RAG, or should we just do prompt engineering? This is from project to project very different. And I think nobody out there may have a perfect overview of all the capabilities which are out there. Good scientific practice, we have to learn that, and in particular, also the language model developers themselves have some stuff to do in order to make large language models more trustworthy. So we are talking here about an entire huge research field, trustworthy AI. And just a reminder at the end, we are responsible for AI-generated content. So when you use this technology in a scientific project, you should disclose it, that's damn clear. And you should also be always careful with what these tools are producing for you, because at the end, you are responsible for the output, not the language model. Okay, with that, I would like to acknowledge some people who were helping me, in particular of the benchmarking project. Also the communities, I'm very happy to be part of the funding agency, CZI in particular, who is funding GloBIAS. And you find here again on the right the link for downloading the slides. And with that, I'm open to questions.
Thank you very much. So there are several questions, and Esteban, can you read out the questions? Yeah.
Yeah, absolutely. Well, first of all, great talk, Robert. I will start with one of the last ones just because it's more relevant to something you just were talking about. Yannick asked, what about authorship issues? When describing some QPath script I wanted to use with GitHub Copilot, it generated automatically comments with the author name in the script, Bitbankhead. I think that might be because of the scarce QPath and Groovy examples available in the training data.
That's amazing. I have never seen such a case. I just have heard about those. So, I mean, if you come to the point where you see, for example, that there is code obviously taken from the examples of a certain library, you should always be, you can reach out to the authors of this particular library. On the other hand, I would say, I'm not speaking for Pete now, I'm speaking for myself, but we put these examples online so that you copy paste them. And you do not have to make us co-authors because of that. So if the large language model is obviously using code from the online documentation, I think that's perfectly fine. Yeah.
Yeah. I have another question. This is maybe more open to the audience, but I think your answer will be very valuable. Someone asked, does anyone find that from a particularly long prompt, some parts of the prompt string come back as part of the answers?
So I've never seen that with commercial large language models. I have seen that with cheaper open source models. And I would refer to the benchmark again. Have a look at this benchmark in very detail. You may come to the conclusion, that's my conclusion at the moment, that there is no open source model at the moment which is as capable as the commercial tools. They are far away from the commercial tools. So that's why we have this benchmark to also guide the community to develop further in this direction. At the moment, the open models are not so capable, unfortunately.
Yeah. Then we have Luciano, who asks, well, first says that thank you for a great talk, Robert. And can you say a few words about what constitutes a quote unquote good data set for training or fine tuning an LLM? Any good examples you can share? And also, what about costs of training and fine tuning an LLM? Can you share your experience in this? Also, what about the cost and setup for fine-tuning a vision transformer? So I can repeat the questions if it's
yeah, no, so vision transformer I have not fine-tuned yet. I would love to spend my entire day on this, but I do not have the time. I was fine-tuning, in fact, some large language models, and the notebooks or some notebooks for doing that are linked in my talk, so you can feel free to try it out. If you fine-tune a large language model on the OpenAI platform, you pay typically per fine-tuned model in a range of something like 20-30 cents. And that just means for this particular data set I have there with my notebook. So if you have something like 100 small samples, I will explain in a minute what these samples are. If you train a large language model like GPT-4 Omni with 100 samples, you pay something like 30 cents. So that's the order of magnitude. And these samples samples I was working a lot with are discussions. So if you have, for example, a list of question-answer pairs, or even longer stuff like multiple back and forth question answer things, you can use them as training data for fine-tuning a large language model. The challenge here is to find for our domain specifically online discussions, which are good for fine-tuning. For example, I was thinking at some point, maybe we can take the image SC forum and take all the discussions there and fine-tune a model with that. And I gave up on this quite early because these discussions are, the majority of these discussions are not like somebody phrases exactly the question they have and an example code limit which does not work. And then there's a response below which exactly solves this issue. So they are not so clean. There's often back and forth. Oh, can you post image and what? There's a lot of back and forth. And this is not so well suited for fine-tuning a language model. You have to have clean discussions about this is my problem. What is the solution? And then the response must be a really valid, good solution. If you have sets of those, you can fine-tune a language model which would then give this answer. And again, the notebooks are linked there. There's also a data set you can download where I have some discussions which you can use for fine-tuning, but the big, good data set, I'm not aware of any.
Yeah, we have a lot of questions. Someone asked, do you think that in the future we will get a separate language model or a language vision model only for medical domain or pathology at least?
I think, oh God, so for the medical domain, there are already some language models, but maybe not in the image analysis domain yet. I think also for pathology, there are models already available. I could not now immediately link one, but there is a group in Dresden. Maybe I will just say the name and you can maybe later Google and check what they are doing. Niklas Carter is a professor of clinical AI at the TU Dresden, and they are working in this direction. So either they are directly involved in some of these models, or they know of some. So I've seen something in the context of his name. So these things exist. I'm also convinced that sooner or later we will find a generic bioimage analysis language model. Maybe we find multiple small language models, one for Python, one for ImageJ macro, and maybe also a language model which doesn't program at all, just gives human answers. Hey, try out this plugin. So I presume that sooner or later we will have these kind of things. Yet we do not have one, or at least I'm not aware of any. But what we have are these retrieval augmented generative solutions, like, for example, the BioImage.io chatbot. Also, BioBob is one of those tools, so there are some out there already.
Okay, another question, Stefan asked, on slide 7, you said that letting LLMs produce code is an approach to make LLMs answers more reproducible. However, the code generated by LLMs could be different. If you ask twice, for example, it could produce a print A in the first run and print a exclamation mark in a second run. Thus, I am not sure when you claim letting LLM produce code is a way to overcome issues with reproducibility. Can you clarify on this?
Yes, so maybe I phrased it wrongly. I also took care to write it correctly on the slide. So the output of LLMs is maybe not reproducible. But if the LLM produces code, the execution, the outcome of this code is reproducible. So you do not regenerate the code over and over. You take code generated from an LLM and then you use it in your science. Also, there's one step in between, which I would like to highlight. You can modify this code and you can make sure that it has the right output. So basically eliminating the LLM from the daily work and just having the LLM supporting you in setting up the workflow and writing the code in the first place. And then we have afterwards something that is reproducible because we can execute again and again the code.
Okay, we have around more or less 3 more questions. How are we doing on time? Do we have time for this?
I have time,
think,
but we are at the limit.
Yeah. So we have to finish because it's 11 o'clock. I also have questions, but let's just stop and then maybe we continue. If there's some questions, we can make a thread in image.sc forum. I know forum image.sc.
Yes, let's continue discussing that.
Yeah. So I mean, for 3 questions, we forward this maybe to, I think Maria can do this, right? Is assigned for this. Okay, so thanks a lot for those who has participated, listened to this talk. If there's more feedback, we can do this in the forum.image.sc. So thank you very much, Robert.
Welcome.
Looking forward, and he's going to chair the third seminar, right? So you see him soon. Thank you very much. Okay, bye-bye.
Thank you. Bye.
Ciao.